talk and learn.
Tara!
Hiya, Marco. What's up?
My friend Kevin needs a little help studying for his Earth Science test. Do you think you could pencil us in for a session?
Well, I do know a thing or two about Earth science. And I hear that you're a real whiz at reviewing for science tests.
Thanks, Tara. Kevin is already waiting for us at my super science station. Off we go!
Marco! Tara! Boy, am I happy to see you! I need to get ready for my Earth Science test.
Glad to help, kid. Earth science is kind of my specialty. When you study Earth science, you learn about astronomy, geology, meteorology, and more. Let's start by talking about our solar system. Tell me what you know.
Well, the sun is in the middle of the solar system, and it provides us with light and heat.
Good. You know anything else?
There are 8 planets that orbit the sun, but I always have trouble remembering their order.
I know a fantastic way to remember the order of the planets. Hello? Who's calling? Professor who? Oh, you're Kevin's mom! His snack is ready. Okie dokie, we'll be right there. Great news! Kevin's mom would like to serve us a little snack.
Sounds good to me.
So, Kevin, I didn't know that your mother was a professor.
Oh yes, she's very educated.
Here you go. Enjoy.
Oh my, what just happened?
My very educated mother just served us nachos.
That's it. That's the order of the planets.
Huh?
I see what he's getting at. Take the first letter of each word in the sentence. My very educated mother just served us nachos. And that will give you the first letter of the name of each planet.
My Mercury. Very Venus. Educated Earth. Mother Mars. Just Jupiter. Served Saturn. Us Uranus. Nachos Neptune.
My very educated mother just served us nachos. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
Exactly. My very educated mother just served us nachos. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
Hey, that's pretty cool. That makes it easy to remember the planets.
Great! Now back to the Solar System Learning Center at my Super Science Station.
But what about the... Aw, the nachos.
Tough going, kid. But nachos aren't the only things in life. And the planets aren't the only things that orbit the sun. Take a look at this.
Wow! That's pretty cool, Tara! What are all these chunks of rock between Mars and Jupiter?
That is known as the asteroid belt. The objects in this area range in size from dust particles all the way up to Ceres, which is 900 kilometers in diameter. Ceres is actually considered a dwarf planet because it has a large enough mass to have a rounded shape. But as you can see, it's not large enough to have cleared its orbit around the sun. By that I mean there are other objects in the same orbit with Ceres. All of those other chunks of rock and metal are known as asteroids.
Is Ceres the only dwarf planet?
Nah, we've got more. Every so often, a group of professional astronomers from around the world meet to assign names to objects in space. 3 dwarf planets they've named are Ceres, Pluto, and Eris.
Looks like there's another asteroid belt further out.
That's called the Kuiper Belt.
Whoa! What's that?
Oh, that's a comet. Comets are collections of ice, dust, and small particles of rock. Most have long oval orbits. When they pass near the sun, their ice melts and evaporates. People on Earth see comets as huge glowing balls with tails made of gas or dust, trailing millions of miles behind them.
All of this is pretty cool, but how does it fit into Earth science?
Learning about the solar system is important for Earth science because what happens in space affects things on Earth. For example, let's take a closer look at how the Earth and Sun interact. See how the Earth goes around or orbits the Sun?
Yeah, Marco, I remember that from science class. It takes a full year for one revolution around the sun, and that's what causes our seasons.
Explain to me how the Earth's orbit causes the seasons.
Well, I know it has something to do with the tilt of the Earth, but I never really understood that part.
Let me see if I can help. When does the sun feel warmest? Early in the morning or around noon?
It's warmest around noon.
Correct. That's because the sun's rays are more direct around noon. In the morning when it's cooler, the sun's rays are more indirect.
So, the Earth flips back and forth?
Oh, no. The Earth keeps pretty much the same tilt. But watch, as she moves around the sun. See? Here the northern hemisphere gets more direct sun, so it is summer there.
And since the southern hemisphere gets the indirect light, it's winter?
Now you've got the idea. If we keep moving around until we get over here,
then it's summer in the southern hemisphere and winter in the northern hemisphere. Wow! Actually seeing it in action makes it easier to understand.
then take a look at this. See how the Earth rotates on its axis? It goes around once every 24 hours.
And that's what causes day and night. The parts of Earth facing the sun are in daylight. As the Earth rotates, the sun seems to set in the west.
Super! I think you've really got a good idea about how things work in our solar system. Here, take one of these, kiddo.
Tara, I don't think it's going to be raining anytime soon. Inside the science station.
I wouldn't be so sure.
Looks like a flash flood. We got here whether or not you wanted to.
Oh, brother.
Here at the Water Cycle and Weather Learning Center, we'll learn how the water cycle affects weather on Earth.
The sun provides the energy that drives the whole water cycle. As the sun heats water on Earth, water evaporates into the air. As the water vapor cools in the atmosphere, it condenses into small water droplets that form clouds.
When the water droplets get too heavy, they precipitate back to the ground. Then the water accumulates in aquifers, rivers, lakes, and the oceans.
And the whole thing can start all over again. Water turns to vapor by evaporation. Clouds form slowly in the sky by the process of condensation.
When the droplets get too heavy, they fall as precipitation. Rain or sleet or snow that melts. Then comes accumulation.
Evaporation. Condensation. Precipitation. Accumulation.
Okay, I think I understand how the water cycle works, but why does it rain and snow places other than over the water?
Good question. We get rain and snow and other precipitation in all kinds of places because the sun heats the earth unevenly. Land heats and cools faster than water. And we know that it's warmer near the equator than the poles.
All of this uneven heating keeps cold and warm air moving and it makes changes in air pressure. Here's how those air pressure changes cause wind. Cold air weighs more than warm air, so the pressure of cold air is greater. When the sun warms the air expands, gets lighter, and rises. Cooler, heavier air moves to where the warmer and lighter air was. In other words, wind usually blows from areas of high air pressure to areas of low air pressure.
Now, warm air can hold more water vapor than cold air. So as the air gets colder,
You get condensation and then precipitation.
there you go. But it is the temperature of the air that determines the kind of precipitation. Rain happens when drops of liquid water fall on the surface of the earth.
Snow forms when the air is so cold that water vapor turns directly into ice without ever passing through a liquid state. If the air is cold enough, the snow will fall all the way to the ground. Otherwise, it might melt into rain on its way down.
Sleet refers to water droplets that freeze on their way down through really cold air. Unlike snow, sleet goes through a liquid state before freezing. The result is that sleet is not light and fluffy.
Hail is like mega sleet. When it hails, large balls of ice fall from the sky.
Hail forms in a more complex way than sleet. As ice crystals start to fall, wind carries them back up high into the clouds. This happens over and over, and the crystals grow each time. Eventually, they get too heavy and fall hard.
That's wild, Tara. I never knew weather could be so complex.
And that's just the surface, kid. But it's enough to get you started. Ooh, those nachos aren't setting so good.
Are you okay?
She'll be fine, but I'm a little worried about us. If there's an earthquake!
I feel much better now.
That's nice, but where are we?
Just where we should be, in the Geology Learning Center.
This is where we can learn about different kinds of rocks and how they're made. Take a look at all these layers of rocks. Little bits of earth were washed downstream. They settled to the bottom of a river, lake, or ocean. Layer after layer was deposited on top, so they were pressed down more and more. Over time, the layers turned into a type of rock called sedimentary rock.
That's right. Sedimentary rocks make up about 3/4 of the rocks at the Earth's surface. Sometimes they can give us clues about what the environment was like when those rocks were formed.
How can they do that?
Well, sometimes dead plants or animals get buried in the sediment. They get covered up by new layers of sediment and sometimes become fossils.
Some fossils are actually parts of an animal, like its teeth or bones that have turned into stone or fossilized. Others are trace fossils, like dinosaur footprints or tunnels made by worms.
But most fossils are casts. The dead plants and animals decay after the sediment is turned into rock, leaving behind a hollow mold. Salts or other minerals can fill the cast and hold its shape.
Fossils found in the same layer of sedimentary rock are from things that lived around the same time. As new layers form on top, the fossils get buried deeper and deeper.
I think I understand. So, the deeper the fossils are found, the older they are?
You've got it! And sometimes large amounts of plants are deposited in sedimentary rocks. If they are compressed under a lot of pressure for a long period of time, they turn into carbon. This gives us coal, oil, natural gas, and petroleum.
I guess that's why they're called fossil fuels.
You bet it is. And let me tell you, fossil fuels are really a gas.
Oh, brother.
Okay, sedimentary rocks make up about 3/4 of the rocks at Earth's surface.
You got it.
What about the rest of the rocks? What are they?
Glad you asked. There are two other kinds of rocks, igneous and metamorphic.
Igneous rocks form when molten rock cools and becomes solid. Molten rock is called magma when it is below the Earth's surface.
But sometimes magma pushes up through cracks to the surface of the Earth. Then it is called lava.
Oh, I just love a good eruption.
Stop that! When lava cools, it becomes a kind of igneous rock called volcanic rock. Basalt is the most common type of volcanic rock. Most of the rocks on the ocean floor are basalt.
Igneous rock can also form when magma cools slowly and becomes hard while it's deep underground. Rocks that form this way, like granite, usually have large crystals.
Fossils are not usually found in igneous rocks. The heat of a volcanic eruption tends to destroy living things and only rarely preserves any evidence of them. However, fossils may be found in volcanic ash deposits, which are actually a kind of sedimentary rock.
That makes sense. Sedimentary rocks are made from sediment, and igneous rocks are made when molten rock is cooled. But what about metamorphic rocks? How do they form?
Good question, kiddo. Metamorphic rocks are rocks that have morphed or changed from one kind of rock into another. Metamorphic rocks were once igneous or sedimentary rocks, but movement of the Earth's crust caused them to change.
Just moving the rocks changes them?
No. Try pushing your hands together very hard. Do you feel heat and pressure?
Yeah.
When the Earth's crust moves, igneous or sedimentary rocks get squeezed by tremendous pressure, which heats the rocks and pulls them like taffy. The original rock is changed by this heating and pulling, and it becomes a metamorphic rock.
As you might guess, any fossils that were in the sedimentary rock will now be in the metamorphic rock. But those fossils may be stretched and deformed because of the heating and pulling.
Bummer.
Metamorphic rocks are the least common of the three kinds of rocks. Slate and marble are two examples.
Wow, that really rocks!
Whoa! What's this? A rock concert?
As a matter of fact, it is! Ladies and gentlemen, please welcome all the way from Little Rock, Arkansas, the Pet Rocks!
All right!
Sedimentary. Igneous. And metamorphic. Three kinds of rocks. Three kinds of rocks. Sedimentary.
Although two rocks may be formed the same way, they can be made up of different kinds of minerals.
That's right. To identify the minerals in rocks, scientists use properties like color, luster, hardness, and streak.
Look at these! I wonder what minerals they are. Hey, if I describe their properties, that might help me to identify them.
Bravo! Now, the color of a mineral is the first thing people tend to notice. But be careful! Most minerals can occur in more than one color.
Luster describes how light is reflected from the surface of a mineral. The two main types of luster are metallic and non-metallic.
The hardness of a mineral is its ability to resist scratching. The Mohs hardness scale uses 10 minerals to rank hardness.
Take a look here. A diamond is the hardest naturally occurring substance with a hardness of 10.
And talc is very soft, so it only has a hardness of 1.
That's all good and fine, but how can I find out the hardness of the minerals in this box?
With a little scratching. Not that kind of scratching. We'll use minerals and objects from the Mohs scale. If your mineral sample can scratch an object, say this penny, then it has a higher hardness.
Let's try this one.
Ooh, good choice. I like the nice metallic luster.
Can it scratch a penny?
Looks like it does, Marco. That means this mineral has a hardness higher than 3.
That's the way to do it. Now try scratching this quartz.
Nope. And look, the quartz will scratch my mineral sample.
So it has a hardness between 3 and 7.
We could keep on scratching away with different materials from the Mohs scale to narrow it down even more. But I think you get the idea.
I sure do. Thanks, Tara.
Another way to categorize minerals with a hardness lower than 7 is to determine their streak.
Streak? Does that mean some of them have racing stripes?
Nah, the streak of a mineral is the color of the powder it leaves when you scrape it across a streak plate. We know your mineral has a hardness lower than 7, so...
Red? That's not what I would have guessed at all.
Don't feel too bad, kid. Science is full of surprises. Have a look at this table here.
Do any of those descriptions match your mineral?
Let me see. Steel gray, hardness 5.5 to 6.5, rust red streak, metallic luster. I'll bet this is hematite.
That's the way to do it. Great job. Well, kid, your earth science knowledge is really building up.
It looks like something else is building up under my chair. Hey, that sort of looks like a volcano.
I guess it was a volcano. And just look where it brought us.
Ah, the Topographic Learning Center. This is the perfect place to learn about how the surface of the Earth changes.
Seems like a volcano would be pretty good at changing the surface.
Tell me about it, kid. These aren't pimples, you know.
I had a friend do a science fair project on volcanoes. She told me there are several types.
She told you right. There are shield volcanoes, cinder cones, stratovolcanoes, and more.
That's a lot of volcanoes. So, what's the difference between the types?
Shield volcanoes are built by layer upon layer of lava. Their eruptions travel great distances from a central vent or group of vents, so they have broad, flat, rounded shapes.
They kind of look like a shield lying on the ground.
That's a great way to remember the name. But while they may look flat from above, they can still get pretty tall. Mauna Loa is the largest shield volcano. Mauna Loa means long mountain, but it stands over 13,000 feet above sea level. and it rises over 28,000 feet from the ocean floor. It would be the world's tallest mountain if it weren't mostly underwater.
Maui wowie!
Actually, it's on the Big Island of Hawaii.
The eruptions of shield volcanoes usually don't have much ash, and they are fairly safe for scientists to monitor. But some other kinds of volcanoes can throw hot ash and cinders into the air. These can form a pyroclastic flow, which travels very fast and burns almost everything in its path.
That's the truth. The temperature of a pyroclastic flow can reach over 500 degrees Celsius.
Whoa! What kind of volcano can do that?
Stratovolcanoes can. They are quite beautiful, like yours truly, but they tend to be tall and symmetric with steep sides. A few stratovolcanoes that you might have heard of are Mount Fuji in Japan, and in the USA, you'll find Mount St. Helens and Mount Rainier in Washington State, and Mount Hood in Oregon. Not Oregon, Oregon.
Those stratovolcanoes really are beautiful. What about cinder cones?
Ah, the little guys.
You can often find cinder cones on the flanks of shield volcanoes and stratovolcanoes. When a cinder cone volcano erupts, cinders of lava are blown into the air and fall around the opening of the volcano.
The pile of cinders forms a small oval-shaped volcano that can grow to about 1,000 feet, but some are much smaller. Many cinder cone volcanoes have a bowl-shaped crater at the opening.
Hey, Marco! What causes volcanoes in the first place?
To explain that, let's dig a little deeper. Deeper into the earth, that is.
Earth is divided into 4 layers: the solid inner core, the liquid outer core, and the mantle.
That's the thickest layer.
And last and least is the crust.
Least because it's the thinnest layer. The rocky outer crust is made of plates that fit together sort of like puzzle pieces. These plates move a little bit each year as they slide on top of a weak layer of the mantle.
This hotter, deeper layer of the mantle can be pushed and pulled like putty. The whole process is called plate tectonics.
The edges of the Earth's plates touch each other. As they move, the plates may just slide past each other. But the plates can also spread apart or even crash together.
Sometimes, when 2 plates collide, large mountain ranges, such as the Himalayas, are formed. That happens if the 2 plates have the same density, so they fold as they move together, much like 2 kitchen rugs pushed together.
That explains mountains, but I wanted to know how volcanoes are formed.
Hold your horses, kid. If colliding plates have different densities, one plate can be forced back down into the deeper regions of the Earth. That plate can begin to melt when it reaches a depth which is hot enough.
The molten crust rises back towards the surface where it helps make volcanoes and islands.
Whew, that's a long process. Is that how all volcanoes are formed?
Well, no. Here's another way. As the plates move, hot spots under the crust may find weak places in the plates or between 2 plates that are moving apart. This will allow magma to come to the surface from deep within the Earth. The result is a volcanic eruption, which can add new landmass to existing land or even form new islands.
Okay, let me get this straight. Volcanoes can form where the plates are pushing together, where they're pulling apart, or anywhere the Earth's crust is weak.
That's the way the cookie crumbles.
And the Earth's crust, too. I cracked myself up. Oh, that's a good one.
Oh, Marco. Now that you have an idea of how Earth's surface can be built up, Let's talk about how it can be worn down.
Weathering is the process that causes rocks to crack and fragment.
Since rocks form in different ways and are made up of different minerals, they react differently when exposed to temperature changes, moisture, particles in the air, or pressure changes.
I suppose that means there are different kinds of weathering.
That's right, Kevin. One thing that causes weathering is frost. When water freezes, it has an unusual property. Unlike most materials that contract when they are cooled, water expands when it solidifies into ice. This can put incredible pressure on rocks. Water gets into the pores or cracks of the rocks and then freezes.
So when the water freezes, it expands and causes pieces of the rock to break off.
Right. Another kind of weathering is abrasion. That can happen when rocks rub against each other, like when a rock rolls downhill or when it tumbles in rivers.
Wind can cause abrasion too. Wind sometimes carries dirt or sand that can wear down rocks as it blows against them.
Plants like moss and lichen can wedge their way into pores, crevices, and cracks in rocks. Seeds from other plants can get into crevices too. As they grow, they cause the rocks to crack apart.
I heard that wetting and drying of rocks can make them break up.
Oh, yes! The combination of wetting and drying is very effective at breaking up clay. That's because clay swells when it gets wet and then shrinks and crumbles as it dries.
Oh, I get it. The process of wetting and drying only weathers some kinds of rocks.
Sometimes rocks break down because the minerals they are made of react with chemicals in water or air. For example, carbonic acid is created when carbon dioxide dissolves in water. And this acid can dissolve limestone and eventually cause the formation of caves and caverns.
Ooh, look at the stalactites and stalagmites.
You're a regular little spelunker, huh?
Stalactites hold tight to the ceiling of the cave, and stalagmites might reach the ceiling someday.
What a smarty. Now, erosion is simply the moving of sediments or rock particles. Moving water is the most powerful force of erosion on Earth. The world's rivers deliver about 20 billion tons of sediment to the oceans each year.
That's a lot of erosion.
And that's why you can see fan-shaped deltas at the mouths of some rivers, such as the Nile. V-shaped valleys, canyons, and gorges are also carved by streams and rivers flowing through the mountains.
Moving air, or wind, is another important mover of sediment, especially in dry regions. When tiny sand grains are lifted and carried by the wind, they can sculpt rocks into a variety of shapes. Sand dunes are hills of sand deposited by the wind, such as those at Great Sand Dunes National Park in Colorado. But of all the things that cause erosion, my favorite is a glacier.
Glaciers form when snow piles up over time and turns to ice. The glacier begins to flow outwards and downwards under the pressure of its own weight. Like great rivers of ice, glaciers have sculpted mountains and carved out U-shaped valleys.
Valley glaciers flow down valleys, and continental glaciers, such as the ones on Greenland and Antarctica, flow outward in all directions. Glaciers reshape the underlying and surrounding landscape as they move by eroding rock from one place and depositing it in another.
That's called deposition. Glaciers, rivers, and wind are major forces of deposition that can build up the earth in some places.
And I think I've got the scoop on erosion. Erosion is when the earth is worn down. It can happen because of water, wind, or ice.
That's right, kid. Weathering and erosion work together to reshape the surface of the earth. Water and cracks of rocks can turn to ice in the winter. and make the cracks bigger. Over time, bits and pieces of the rock break off and fall away. Wind can pick up these small bits and wear down weaker parts of rock. Rain can wash the small bits away.
Over time, these processes can work together to leave interesting formations, such as the arches in Utah or the hoodoos in Bryce Canyon.
Canyons look like fun places. I'd like to travel to see them someday.
Well, right now we need to travel to our next learning center. Right this way.
Whoa! Hey, wait, Marco! I think my chair ran out of gas.
Uh-oh, it looks like we need an alternative energy source. Don't worry. Balance this on your head.
Okay, but how will this solar panel help? We're indoors.
Just you wait and see.
Yeah!
Hiya, boys. I see you used a perpetual resource to get here.
Perpetual resource?
Yep. A perpetual resource is one that cannot be affected by human use. Perpetual resources are also called inexhaustible resources. They include things like solar energy that can be converted into electricity. Solar energy can also be used to heat water or air for homes and businesses.
Sounds like we should use solar energy for everything.
Well, solar energy is very dependent on the time of day, the time of year, and the weather. So, in order to be efficient, a large surface area is required to collect the energy from the sun. But scientists are working on ways to get around that.
Is solar energy the only perpetual resource?
Oh no, there's always the wind.
Remember that the wind is caused by uneven heating of Earth by the sun, so it's an indirect form of solar energy. The wind blows stronger and more consistently in some areas. Wind turbines and wind farms can be built in those places to convert the wind energy into electricity.
And there's also geothermal energy. Heat from the earth can be used to make steam or hot water to heat buildings or generate electricity.
Some scientists are even looking at ways to utilize the oceans to produce energy for us without causing any environmental damage. They've come up with a few ways of tapping the energy from tides and waves.
We might even find a way to use temperature differences in the ocean to produce energy. In some regions, the surface water can be 40 or more degrees Fahrenheit warmer than the deep water.
So, perpetual resources include solar, wind, geothermal, and ocean energy. What other kinds of resources are there?
Glad you asked, kiddo. There are renewable resources and non-renewable resources.
I've heard of renewable resources. They can be replenished as fast or faster than we use them.
That's true. But the problem is that usually the demand for resources like wood, crops, soil, and water increases over time. If the demand gets too high, these resources cannot be replenished fast enough. We have to be careful and keep things in balance.
That does sound like a good thing to do. And what about non-renewable resources? I guess those can't be replenished at all.
When they're gone, they're really gone. Non-renewable resources like natural gas, oil, and coal that we get from fossil fuels will eventually run out if we keep using them.
Energy efficiency and conservation are so important. We need to make non-renewable resources last as long as possible while we are looking for new alternatives.
Energy efficiency is the use of technology to perform the same function with less energy.
Like putting tinting on your windows to keep out the sunlight that heats up buildings in the summertime.
No, that's to make it look cool. Sorry. Energy conservation is any behavior that causes us to use less energy.
Like turning off lights when they're not being used.
Exactly, Kevin. And by using energy-efficient light bulbs, you can save a lot on your electric bill.
Another way to conserve energy is by insulating and weatherizing homes and buildings. That way you use less air conditioning and heating.
You can also save on heating and cooling by placing trees, shrubs, or other landscaping to block the wind and provide shade. But we can conserve other resources besides just energy, such as wood and water.
There are many ways to help save water around the house. Turn off the water while you're brushing your teeth. Take short showers instead of baths. And be sure to fix any leaks.
I worked with my mom to convince the people in our neighborhood to find a garbage service that recycles. We separate out plastic, glass, aluminum cans, and paper for recycling.
Excellent! By recycling, you are not only conserving resources, but you are also helping to keep unnecessary garbage out of landfills.
Yeah, thanks for helping to keep the earth a cleaner place to live, kiddo.
You're welcome, Tara. And thanks to both of you for helping me study earth science. I'm ready to ace my test.
I'm so proud of you.
Well, I should be getting back home, Marco. I'm ready to teleport.
Okie dokie.
Huh?
Oh, Marco.
Hey, science fans! To quiz yourself on Earth science, you can download a practice test at my website. Just visit www.marcothepencil.com. Ciao! Now that we've reviewed some of the material from Earth science, let's see how well you might do on a practice test. For those of you following along, you might want to use pause when a question first comes up to see if you can choose the right answer before Kevin. Let's begin with some questions about the solar system.
1. Look at the diagram of our solar system below. What is the name of planet 5?
Dun, 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 dun.
Oh yeah, Marco. My very educated mother just. That starts with J. Jupiter. That's answer B.
Fantastico! Sometimes you might be asked to fill in your answer right on the page with the questions, but this test has a separate answer sheet. Be sure to ask your teacher how you're supposed to mark the answers on your test. Let's put the test over the answer sheet just under the question we are answering. That way we can make sure we fill in the right bubble.
2. Which objects in our solar system have long tails when they are close to the sun and are made mostly of rock and ice? A. Planets. B. Asteroids. C. Dwarf planets. D. Comets. The only one of these things I remember having tails are the comets.
You have a great memory! Our answer is D.
Three. What causes day and night on Earth? A. The Earth orbits the sun.
Nah. Earth orbiting the sun combined with the tilt of the Earth's axis is what gives us seasons, not day and night.
B. The moon orbits the Earth.
The moon orbiting the Earth causes the tides to rise and fall on the Earth, but it doesn't cause day and night.
C. The Earth rotates on its axis. I think this is the right answer.
Right you are! See, the sun lights up half of the Earth. The parts that are in the sunlight are experiencing a day. The parts that aren't in the sunlight are experiencing a night.
And if we could look down at the Earth from the North Pole, we would see that the Earth is rotating counterclockwise. So the sun seems to come up in the east and set in the west.
Maybe I should check this last answer just to make certain C is the best choice.
Good thinking, Kevin.
D, the sun orbits the Earth? That's ridiculous. Everyone knows that the sun doesn't orbit the Earth.
That means our answer is C. The Earth rotates on its axis.
Let's move on to questions about the water cycle and weather.
4. What supplies the energy to drive the water cycle?
Can you remember what I told you?
I remember, Tara. You said the energy source that drives the whole water cycle is the sun.
You're really starting to get on my good side.
Okay, so our answer is A, sun.
Great job! Now let's see if you can get this next one.
5. The picture shows a place where air currents will form due to the uneven heating of the Earth. In which direction will air currents most likely move? Let's see. Warm air rises, and the cool air will come in to replace it. So, A, from the lake toward the land, looks right, but let me check all the answers. B, straight up above the lake. No, that's not right. C, from the land toward the lake. That's backwards. D, all of the above. That can't be right.
So our answer is A. I'm glad that you look at all of the answers carefully. Some students make the mistake of choosing all of the above every time it's an answer choice.
Not our boy. He's too smart to do something like that.
Aw, thanks, Tara.
Now, do you remember anything from the Geology Learning Center?
I sure do. Sedimentary rock is formed in layers, and the deeper the layers, the older they are.
That ought to make this next question pretty simple.
6. The rock column above shows the layers in a sedimentary rock formation. The 3 core samples to the right were taken from the rock column on the left. According to this information, which fossil is the oldest? Well, the deepest layer is layer 1, so it is the oldest. Since the fossil on the bottom of core sample X came from layer 1, it is the oldest fossil. So the answer is C.
Super! Let's see if you can get the answer to this next geology question.
7. Why are most fossils found in sedimentary rocks? Let me read through the answers. A. Fossils can be distorted in metamorphic rocks. That's true.
You bet it is! Metamorphic rocks are made by pressure and heat on other types of rocks. That could really mess up any fossils in the rock.
But let's look at all the answer choices. B. Igneous rocks were too hot when they formed. Considering that igneous rocks were made of molten rock, I'm sure they were too hot to preserve any fossils.
What about C?
Sedimentary rocks are best for preserving organisms. This one's also true. So the answer must be D, all of the above.
Great job!
You're a real gem. We'll take a look at one more geology question.
8. The chart below shows part of Mohs hardness scale for minerals. A student is testing an unknown mineral for hardness. The unknown mineral is tested against fluorite, but neither mineral scratches the other. Which of the following conclusions can the student accurately make? If the unknown mineral didn't scratch fluorite, and fluorite didn't scratch the unknown mineral, they both must have a hardness of 4.
Keep that in mind while we look at the possible answers.
A. The unknown mineral and orthoclase will not scratch each other.
Orthoclase is harder than fluorite.
So orthoclase would scratch the unknown mineral. A is wrong. B. The unknown mineral will scratch calcite. That's true.
Yup, calcite is lower on the hardness scale. But let's not be too hasty. Read the last two answer choices.
C. The unknown mineral will scratch orthoclase. That's the exact opposite of what would happen. D. The unknown mineral will not scratch gypsum.
That doesn't seem right.
No way! Gypsum is even lower on the hardness scale than calcite.
So our answer is B.
This kid has a mountain of information in his head.
You think so? Let's see if he remembers what was said about Earth's changing topography.
9. Mountains may be formed when A. Volcanoes erupt. That's true. Some of the volcanoes even have the word mount in their name, like Mount Fuji. But I remember that mountains are formed other ways too. Let me check the rest of the answers. B. Plates of the Earth's crust collide. That's true too. Tara said the Himalayas were formed that way.
Great memory, kid.
C says both A and B. And D says none of the above. So I'm going to have to say that C is the right answer.
Perfecto!
Ten. Which of these processes can be caused by movement of the Earth's plates? Let's see. The highest mountain range in the world, the Himalayas, were formed by plates colliding. And the islands of Hawaii were formed because of a plate moving over a hot spot. Some of those islands still have volcanic eruptions. That makes all of the answers true.
So our answer is D. All of the above.
Let's see what you remember about weathering and erosion.
11. Moving water was the most important factor in forming which of these? A. Sand dunes at Great Sand Dunes National Park. No, Tara said those were formed by wind. B. The Grand Canyon. I'm pretty sure that was formed by a river, although I don't know what the name of the river is.
That would be the Colorado River.
C. The Andes Mountains. From what we discussed, mountains are built from volcanic eruptions or plate tectonics, not moving water.
You've got a good head on your shoulders, kid.
D. Kilauea Volcano. That's made out of flowing lava, not moving water. So the answer is B. The Grand Canyon.
Nice work!
Ooh, that's a nice picture. I'd like to go there someday.
And the man at the bottom of the picture gives you some perspective as to how large the arch really is.
All right. Let's get down to business. Read the question, please.
12. The land formed below is an arch found in Arches National Park in Utah. Which type of weathering or erosion is not responsible for shaping this arch? Here's one of those questions that has to be read carefully. The word not makes a big difference in the answer I'll choose. Let's see. Tara talked about the combination of water, ice weathering, and wind all playing a part in forming arches. So I think the answer is A, glaciers, because glaciers did not help shape the arch.
Right you are!
You're a smart kid. So let's see how bright you are when it comes to energy and resources available on Earth.
No problem. 13. Which of the following is a renewable resource? A. Tree. That's renewable as long as we don't use them faster than new trees can grow. I think this is the answer, but I'll check them all to be sure.
I'm so glad you have good test-taking skills.
B. Natural gas. That's a non-renewable resource. C. Solar energy. Ah, this is one of the perpetual or inexhaustible resources you told me about, not a renewable one. No matter how much we use the perpetual resources, they'll always be around. D, oil. No, that's a fossil fuel. All fossil fuels are non-renewable resources, so the only renewable resource here is the tree.
That makes the answer A.
Watering plants and grass in the early morning is one way to conserve water. Why? A. Plants only absorb water in the morning.
No, plants can absorb water any time of day. Take a look at the next one.
Okay, Marco. B. Less water evaporates into the air in the cool morning. This leaves more water for plants to absorb and allows shorter watering times. That's true. C. Water used in the morning can be recycled in the evening.
That doesn't make sense. If some sort of system is in place to catch unused water to be recycled, it can be used anytime, not just in the morning.
D. Water is more pure in the morning. This one doesn't make sense either.
I guess that means you're sticking with answer B then.
Yep.
And now for the last question.
15. Which of the following is not a way to help conserve energy? A. Plant trees in the landscaping around buildings. The trees would provide shade from the sun and help to block wind.
Which would help with cooling and heating bills.
But the question is asking which one is not a way to conserve energy. How about B? Turn off machines when they are not being used.
That's definitely a way to conserve energy. Check the next one.
Sure thing, Marco. C. Both A and B. No, those are both good ways to conserve energy. So that means our answer must be D. Take lots of bubble baths.
Wow, you did a great job on this practice Earth Science test.
I agree. Nice work. Hey, science fans, you can download this Earth Science test at my website. Just visit www.marcothepencil.com. Ciao!